Okay, so welcome back. This is Harcourt University as usual, and this is the second question. Now, before I move on, if you didn't subscribe to the channel, kindly go back and do that to support us. Thank you. So, certain data was obtained from an experiment to find the moment of inertia for pulley by Trifilar suspension. So, we are looking for the moment of inertia of a pulley. Now, the mass of the pulley is 12 kilogram. The length of the trifilar strings is 3 meters. The distance of strings on either side of center of gravity R is 150 mm. The time for 20 oscillations is 46.8 seconds. Calculate the radius of gyration and the moment of inertia of the pulley about the axis of rotation. So let's begin by sketching the trifilar suspension. So we have something like this. We have the 3 strings. Of course, the pulley lies in the middle somewhere here. The distance from here to the string is R, and then from here to here is the length, which is given as 153 m, and this one is 150 mm. Okay, so the mass will weigh down here mg. So we begin by writing the equation of motion. So the equation of motion, you have I theta dot plus mgr square on L theta to be equal to 0. Now we are supposed to find I. What we have is the mass of the pulley. We have the length, we have everything here, but what you don't have is I. Now I is equal to mk. I is equal to mk squared. Omega n is equal to 2 pi over period. And then also omega n is also equal to square root of mgr squared all over IL. So if this represents the k component and this represents the m component, omega n is supposed to be k on m. So it's going to be this term over the I. So in everything we're going to have this. So if I represent the m component and k represent this term, where omega n is equal to k on m, then if you put this and this in the equation, we have this as the natural frequency. So from here, we can easily say the period is equal to 2 pi multiplying square root of IL all on mgr squared. Now, what we don't have, the period is 46.8 over 20 because we have 46.8 for 20 oscillations, 46.8 for 20 oscillations. So for one oscillation, what's the time? And that's the period we're looking for. So multiplying 2 pi, multiplying square root of mk squared times L all on mgr squared. So here m cancels m. So from here, it's just a matter of finding the k. So we have 46.8 out of 20 to be equal to 2 pi multiplying square root of k, we don't know, k is k squared. L is 3 meters. Then we have 9.81 multiplying R is 0.15. All right, so quickly, we have 46.8 on 20 divided by 46.8 divided by 20. So we have 2.34 out of 2 pi to be equal to square root of 3k squared all on 9.81 times 0.15, 1.4715. So from here, we square this, then we multiply. So you're going to have to like 1.4715 multiplying 2.34 out of 2 pi all squared, all divided by 3 square root is what? K. So you can do it piecewise. It's up to you, right? You can simplify, you can square both sides, then simplify the thing. It's already simplified. So square both sides, find the solution, you multiply this to it, you divide by 3, then you take the square root. So any of them should be the same. 1.4715 multiplying 2.34 out of 2 pi squared all on 3. So K is equal to 0.261 meter. Okay, so now we know the radius of gyration. Then we are supposed to find the moment of inertia. So I is equal to, the mass is 12. Is it 12? Of course. So I will be equal to 12 times 0.261 squared. And that will be 12 times 0.261 squared. So we have 0.82 kilogram meter squared. All right, so that is that. Once again, if you did not subscribe, kindly do that. Let me have your problems in the comment section. Like and subscribe and share to your friends. Thank you.